Hello and welcome back to PA Academy. So this is example 2 of the video series Mesh Analysis. So if you missed the previous part of this video, that is the introduction and the last example I did, I'll leave a link to it in the description of this particular video. So now this is what we are going to be solving in this example 2. So this is almost similar to the one we looked at in the previous example, but towards the end you are going to be seeing some little differences that will give you more knowledge about mesh analysis. Alright, so now this is the circuit. The question says find the current in each mesh and the current passing through each resistor. So also we have three resistors, 1, 2 and 3, and then we have 2 voltage source. So what we are going to do now is to look at how many mesh do we have. So this is we are having two meshes. So let's pick the this point, that's the node, and then this other points, and then let's call this point A, let's call this B, C, D, E and F. So let's identify the mesh. We have 2 mesh, so this is one mesh, this is mesh 1, and let's take the current that is flowing through this mesh. Let's indicate it as I1. So we are taking clockwise direction for the currents. So for this is mesh 2, let's take the current flowing through it as I2. So let's indicate that this is mesh 2. So since we've been able to identify the mesh that we have in the circuit as 2, and we've taken the direction of our current for each mesh to be in clockwise direction, for mesh 1 I1, for mesh 2 I2. So now let's go ahead and put the polarities. So by now you should be familiar with how to put the polarity. For the voltage source, I said it's always constant. The longer side is positive, the shorter one is negative. Now for the resistor, for this mesh 1, this is going to be plus, minus in this direction. This will be plus, minus, and that's the end. For mesh 2, this will be plus, minus, this will be plus, minus, and that solves that. So now having done that, we can go ahead and then apply Kirchhoff voltage law. So let's go ahead and apply Kirchhoff voltage law for us to get the value of the current that is flowing through mesh 1 and also that of mesh 2. So now let's start with mesh 1. So for mesh 1, the path for mesh 1 is A, B, E, F and back to A. So let me just indicate that. So that's the path that we are considering for mesh 1. So starting from point A, so the first element here we are having is 2 ohm resistor. So multiply by the currents, and from positive to negative, that will be minus 2I1. And when we get here, plus to minus, that will be minus 3 for the 3 ohm resistor, 3I1. Also, this 3 ohm resistor, there are 2 currents that is passing through it, I1 and I2. So because of that of I2, from plus to minus, that will be plus 3I2. So let's continue. Here there's nothing here. Between here and here we have a voltage source which is from minus to plus, which is plus 10 equals to 0. That is applying Kirchhoff voltage law. So now let's simplify this. Minus 2I1 minus 3I1, that will give us minus 5I1. Then we have plus 3I2, then equals to, so if this plus 10 should come to the other side of the equals to sign, it becomes minus 10. So with that, now we can have that to be our equation 1. So that's for mesh 1. So now let's go to mesh 2. So for the mesh 2, the path for mesh 2 is B, C, D, E and then B. So this is the path that we are considering for mesh 2. So now let's start from point B. This is the first element we are coming across, which is 4 ohm resistor. So for the 4 ohm resistor, sorry, this is supposed to be minus, plus, minus. Alright. So for the 4 ohm resistor, so plus, minus in this direction, that will be minus 4, and then the current passing through it is I2, minus 4I2. If you should come here, the voltage source, plus, minus, that will be minus 15. Remember I said this is already a voltage source, already in volts, so there's no need to multiply with I2. So we are going to bring in the 15, then minus because of the direction that we are picking. So now from D to E, there's nothing there. So from E to B, we already have a 3 ohm resistor and a current of I2 passing through it. That is plus, minus. So that will be minus 3I2. Also, we also have plus or minus, and because of I1, that will be from, minus to plus, that will be plus 3I1 equals to 0. So now let's simplify this. We are having minus 4I2 and minus 3I2. That will give us minus 7I2 plus 3I1. This 3I1. So if this minus 15, that's the voltage source, minus 15, if you take it to the other side of the equals to sign, it becomes 15. And what we are having here is our equation 2. Equation 2. Alright, so if we should solve equation 1 and equation 2 simultaneously, so let me write solving equation 1 and equation 2. Solving equation 1 and 2. So we are going to be having our equation 1. So if you should pick it and solve it, pick equation 2 and solve simultaneously, we are going to be having I1 will give us 0.961 amperes. So you can either use your calculator or you solve it manually. And then for I2, we are going to be having minus 7. Okay, sorry, it's going to be giving us minus 1.731 amperes. Now, like I said, there's a little difference here because we are having a negative value here. So what it simply means when you're having the value of your current to be negative is that what it means is that for this particular I2, here we assume a clockwise direction. Now that we are now having a negative value for mesh 2, that means the current is actually not flowing in clockwise, it's actually flowing anti-clockwise. Is that clear? So that is why we are having negative, because we assume it's flowing in clockwise, and our assumption gives us that it is negative. So giving us negative means the current is actually flowing anti-clockwise direction. So that's why we are having negative. So that is the current that is passing through I2 based on. So you can always, in a situation like that, you can always indicate the direction that you use to arrive at your answer as. So if it is like this, you can just clockwise. So that's what brought about that. Alright, so we've been able to get the current I1 and I2. So the next thing for us to do is to get the current that is flowing through each of these resistors. So we have 2 ohms, 3 ohm and 4 ohm resistor. Alright, so the one that we are going to be considering first. So let's start with the 2 ohm resistor. So that will be I that is flowing through the 2 ohm resistor. Alright, so if you look at this 2 ohm resistor, the current that is flowing through it, just like previous example, is what is I1. So it's I1. So that means the current through the 2 ohm resistor is I1, and that is the value of our I1. We've gotten it to be 0.961 amperes. And don't forget, I said you always indicate the direction. So the direction we picked there is correct. So that is in this direction, because the answer is positive. I hope that is clear. So also let's do that of 4 ohms. So the current flowing through the 4 ohms resistor. So if you look at it, the current flowing through the 4 ohm resistor is I2. And we've gotten our I2 to be minus 1.731 amperes. So, but we cannot indicate it as minus here. So we'll go ahead and write 1.731 amperes. Now, this is the direction that we picked. And I've said it that since we don't want the negative, so we are going to indicate that it is in opposite direction. I hope that is clear. This is the direction that we assume for I2, but since our answer is negative, that means the answer is still 1.7, but because of the direction we pick, we are going to be having a negative answer. So this as I2. So this as I. So our I2 will be 1.731 amperes in this direction. So always indicate in this direction. So now let's do the last one, which is going to be I3. So the current that is flowing through the 3 ohm resistor. So like I said, to calculate I3, since we have 2 currents that is flowing through it, so what we consider is the one with the higher value minus the current with the lower value. So if you look at I1 and I2, the value of I1 is higher than that of I2 because of this minus. So I hope you know that. So if you have 2, 1, 0, minus 1, minus 2. So that means 2 is higher than minus 2. So that means we are going to be having I1 minus I2. So that will be 0.961 amperes minus 1.731 amperes. So if you should simplify this, it will be giving us 0.961 plus 1.731 amperes. So by the time we calculate this, all right, so because of my space, let me continue here. Let me just indicate that here. So that means our I3 amperes, if you should add the value of this together, I hope you can see it. So if you should add this together, we are going to be having 2.692 amperes. And now the direction, since it's I1, we are considering this is going to be the direction downward direction. So with this now, we've been able to calculate the current that is flowing through the mesh 1. We've also been mesh 1 at 0.961 amperes. We've also gotten the current that is flowing through I2. This is the current that is flowing through I2 as minus 1.731 amperes. But we decide to take the calculation in a clockwise direction. That gave us minus 1.731 amperes. So that's why I indicated it as in a clockwise direction. But if you want to write it as I2 as 1 without the minus sign, then also indicates that the direction that you pick is what is anti-clockwise. So we've also gotten the current that is passing through each of this resistor. Through the 2 ohm resistor, we've gotten that to be 0.961 amperes. Through the 4 ohm resistor, we've gotten it to be 1.731 amperes, and these are the directions for the current passing through 2 ohms and 4 ohms resistor. For the 3 ohm resistor, we've gotten that to be that is 2 points. There's a point here, 2.69. let me write this properly. So for the 3 ohm that is 2.692 amperes, and the direction is what is downward. That is because the more current from I1 is more than that of what of I2. So if you find value in this, please give it a thumbs up, and if you have any question or any comments, do leave them in the comment section below. And with that, I'll see you all in example 3. Thank you.